Hi, right, I'm back again. Today I would like to talk about designing for space. What is it about space that requires a certain level of rigor and quality, unlike any design that is done for use on Earth? It mostly has to do with two things. The first is that space is far. Once technology is sent to space, you cannot go back and fix it, right? It has to work. It has to work the first time. It has to work the first time well. So your design needs to be on point, and you need to bear in mind that the you have one shot. You just have one chance at this, and if you miss it, you would have lost the mission, and you lost everything that you invested in time and money and human resources. So this is one thing to bear in mind when you're designing for space. The second thing, which is linked to this, is the space environment itself. What do I mean by space environment? When one is designing technology to use on Earth, you consider the weather, you consider under what circumstances it can be used. There are some pieces of technology that you can only use indoors. They will tell you on the user manual to not use it outdoors. There's some pieces of technology you can use in the rain, some you cannot use in the rain. They will tell you, don't use this thing in the rain. There are some things that needs to be kept at certain temperatures. Some needs to be kept under certain levels of pressure, and you are told these. So these are environmental constraints on the development of technology. So what is it about the environment that you need to take into account when you're designing your piece of technology? This is something that we're used to on Earth. So we're used to, on our day-to-day, encountering technology with constraints about where and how we can use it. It is the same thing in space, just that the space environment is particularly hostile. It is brutal. And what is there in space that makes it brutal? Well, in space, first of all, you don't have the protection of the atmosphere. And the atmosphere stops a lot of some of the particles that are in space from getting to us. Now, what am I talking about? You may or may not know of subatomic particles that, well, what does subatomic mean? Sub is basically, lower than or smaller than atomic, than an atom. You probably have a concept of what an atom is. If you consider that a subatomic particle is a particle that is smaller than an atom. And these particles travel at speeds many times that of any bullet you can imagine, and with energies greater than you can probably think of. And these particles will traverse. Is that a word? Am I still speaking English? They will get in contact with the technology that we send there. So there is that. Then there is the fact that the protection from the sun is not the same because we don't have the atmosphere, so it is in direct contact with sun rays, with a lot of ultraviolet that we don't encounter here on Earth. Because it is in orbit, it changes temperature very dramatically depending on whether it is on the sunny side or it is in eclipse. Because as it orbits, sometimes it will have the sun, sometimes it will not, again, depending on the type of orbit. So if you have a piece of technology here on Earth, it will encounter temperatures, I don't know, maybe between room temperature, it could go plus or minus, I don't know, 10, 20 degrees, depending on the weather. Is it summer, is it winter? If it is enclosed, maybe like a computer, and then it starts heating up, you could get to, I don't know, what, 40, 50-ish degrees in there. In space, your piece of technology will be subjected to temperatures of plus 100 and something and minus 100 and something in cycles many times in the same day. This is another consideration, right? Then there is how you get to space to begin with. You need to be launched in a rocket. Not you, I mean your piece of technology, right? And this rocket will shake, it will vibrate a lot, and it vibrates so much that if you don't design to cater for that, you could shake your satellite to pieces just at launch, before it even gets to space. All of these are environmental constraints to take into account. And when you design for space, you need to make sure that these very large variations in temperatures can happen without your mission being jeopardized. You need to make sure that these high energy particles, as they will come in contact with your satellite, because they will come in contact with your satellite, they will. You need to make sure that as they come in contact with your satellites, and sometimes they even cause some errors in your electronics. Sometimes they cause different types of failures in your electronics. You need to make sure that despite all this, your satellite can still function. You need to make sure that even before it gets to space, that it can survive the launch. So you need to do some vibration testing to make sure your satellite doesn't fall to pieces as you launch it. So these are some of the constraints that you encounter when you are sending technology to space. So consider that you cannot go and fix it. The environment is very hostile because all of these high energy subatomic particles, and actually they're not only subatomic, you have some atomic, you have some molecular, right? It is brutal. It is brutal, and I don't want to get into space debris. Maybe in another video I'll talk a bit about space debris. But what you need to know is this is where you're sending your technology. You're not sending your technology to another country. It's not going to stay here on Earth. You're sending it to a place where it will encounter things that it doesn't encounter on Earth, because your phone is not subject to high energy protons, so many that they can cause failures. Your phone doesn't encounter plus 100 degrees Celsius and then minus 100 degrees Celsius many times in the space of 24 hours. Your phone is not vibrated by a rocket so much during a launch, right? So you need to make sure, because the moment you load the satellite, it is on a rocket. That's it, you're not seeing it again. So when designing for space, you need to make sure your design is so robust and so reliable that it will take all this beating and it will still deliver